Welcome sa ating last part ng Introduction to Surveying students. So they are going to present to you the different errors that we are facing on the field, how to eliminate those errors, and what are the definition of your precision, what is the difference from the uh, accuracy, and some of the interrelationship of errors. Okay, let's start. So this is theory of errors. So in conducting a precise field measurement, pag nag-o-observe tayo ng, for example, nagme-measure tayo ng distance, so it is important to know that the error mistakes could be committed and now can apply the different corrections. So pag nag-commit tayo ng mistake, kailangan natin nag-apply ng correction sa field. So will stress only on the common errors and mistake committed on the field and will explain how to reduce and eliminate these errors and mistake. So let's recall first the definition of measurement. We're going to say measurement is the process of determining the extent, size, it could be size, the dimension of a particular quantity in comparison to a given standard. So it consists of several their physical operation which renders a numerical value. Measure tayo ng distance, for example. Again, it could be direct or indirect. So if we compare measurement from in observation, yung measurement is yung including na yung preparation na ginawa natin if you're going to observe a data. While solely ang observation is a single and unadjusted determination of linear and angular value. Okay, so surveyor who works must be performed to exacting the standards from the kung ano yung standards dapat i-meet natin if in conducting a survey. So therefore, thoroughly understand the different kinds of error. So dapat alam ng GE kung ano yung kinds ng error, ano yung mga sources ng error and expected magnitude. When we say magnitude, yung value ng gano'n ba kalaki yung error na pwedeng ma-occur sa field. So, under varying condition. So, in the matter of propagation, only then, they can select the instrument. Ano bang select ang instrument and must prefer in this type of measurement para makareduce ng error. And for also, and we can determine kung anong klaseng correction or kanong klaseng adjustment ang pwede nating i-apply in this type of error. So if we're going to differentiate what is error from a correction, so for the purpose of calculating error, the true value is determined statistically. So after repeated measurements, so yung true value natin is ma-determine lang yan pag series of measurement ang ating gagawin. So we can say that this value now is the true. So when we see error, this is the difference between the measured or the calculated value of a quantity and given or ito na yung ginagamit nating established or true value of that quantity. So yung error natin, formula niya is x minus t, where yung x natin is yung na-measure natin or yung na-observe natin ng mga value, and t is yung ating true value na na-establish. So the correction, that is only the negative value of your error. As you can see on the formula, yung formula ni error, binaliktad lang. So, yung correction is equals to the true value minus your observed value or measured value. Saan ba nanggaling si error or what are the sources of our errors? So, we have the natural, the instrumental, and the personal errors. Ito yung sources. Number one, we have the natural resources. So, yung caused by the variation in the phenomena or caused ng environment na posibleng mag-change yung ating instrument, posibleng, for example, changes in the magnetic declination, changes in temperature, which affects our measurement. We have also the instrumental errors. This is due to imperfection in the instrument used. For example, hindi siya calibrated or during manufacturing ng instrument, meron na siyang error. So if you're going to use that instrument, it possibly our measurement will also lead to an error. So we have here we have the personal errors. So this arise particularly from the limitation of the senses of sight. For example, yung GE natin is di masyadong clear yung paningin niya, and yung graduation ng ating rod, hindi masyado niyang mabasa, or the touch and hearing of the observer, hindi masyadong clear. So, it can cause some of the errors. So, the types of the errors, we have the mistake or blunder. Itong pangalawa is the systematic or the cumulative, si random, and the or. Ito yung tawag na accidental error. So, let's start kay mistake or blunder. Actually daw, hindi siya talaga error because they are usually so gross, which means sobrang laki na ng error in magnitude compared to the other types of error. Ito yung pinaka malaking error. So, tinatawag na siyang mistake. So, it is due to the carelessness of the observer. And observation with the mistake is not useful unless the mistake is removed. For example, nagkamali kang mag-record ng mga value instead of 100 centimeter, yung nilagay mo is 10 centimeter, nagkulang ka paglagay ng 0. So, malaking difference na from 100 to 10. Pwede ba? So, we have here another illustration. So, example scenario lang siya, paano natin ma-determine yung mistake. So, for example, a data collector writes the following data result from a survey measured 6 times. So, sa 6 na beses niyang mineasure ang isang line. For example, nag-measure siya ng line in A to B. So, pabalik-balik siya pag measure ng A to B to ensure ano ba talaga yung length ni A to B. Tapos, ito yung mga data na nakuha niya. We have here 200.01, 200.02, 100.01, 200.01, 200.03, and so on. 200.04. So, as you can see, pag nakita mo yung kanyang data, sobrang, medyo what do you think is the problem of the data? So, we have here item number 3. We have 100.01. So, it's impossible naman na nag-shrink yung length ng line A to B to 100.01. So, it is possible na yung 2 on yung 1 is 2. So, medyo nagkamali lang yung ating recorder. So, this will result into a mistake. Hindi na siya error. Sobrang laki na ng effect ng ganitong klaseng error. So, this is called a mistake. So, anong gagawin para ma-eliminate to? Tatanggalin lang natin sa observation. So, we can omit that value which is 100.01. Then, we can compensate na the measurement. This is a mistake. So, these are common mistake lang na perform sa field. We have here reading the wrong graduation of the tape, which is very common, especially na kung mga student, very common reading the graduation ng tape. Omitting the whole length of the tape. So, pag di tayo nag-start ng 0, and we assume na nag-start tayo ng 0, so, ilang meter yung ating na-omit. Transposition of figures, example, yung GE mo, nag-suggest, or you write 68 meters, and you write 86 meters. So, compare 68 meters to 86. So, that is very far. Misplacing decimal point. Example kanina, instead of 100 centimeter, 100.0 centimeter, yung sinulit mo is 10.00 centimeter. So, malaking difference. Incorrect recording of the field notes. That's why if you record your data, always check your data. Citing the wrong target is one of the common mistakes. Another here. So, the types of error, meron tayong systematic or cumulative error. So, this is defined as being those error whose magnitude, yung gano'n siya kalaki, and algebraic sign can be determined. So, pwede lang natin siyang ma-determine. So, the fact that these errors can be determined, it allows the surveyor to eliminate them from the measurement. So, pwede natin siyang tanggalin para ma-eliminate ang ating errors. So, the error due to the effects of temperature is one of the example. Here, for the definition, it occurs to some deterministic system. So, pwede natin siyang ma-determine when known. Pag alam natin yung nag-create ng error, can be expressed by some functional relationship. It is caused by physical or natural conditions that vary in accordance with known mathematical or physical laws. So, pwede lang natin siyang ma-eliminate. Gagamitan lang natin siya ng mga formulas to compensate these errors. So, examples is error due to the effects of temperature on a steel tape. For example, masyadong mainit sa field. So, yung steel tape natin is nag-i-expand because steel lang yun. So, too much high temperature, it will cause the expansion of the tape. So, these are common systematic or cumulative error. So, equipment out of calibration. So, pwede yung mga tape natin, yung mga mismong total station. So, pag out of calibration. Personal biases of the observer and use of incorrect units. So, it will lead to a systematic or cumulative error. So, the third type of error, we have the random or the accidental error. So, this is associated with the skill and vigilance of the surveyor. So, this is known as the accidental. So, introduced to each measurement mainly because no human being can perform the survey perfectly. So, it's impossible na 0.00 yung ating makukuhang error during the survey. So, some of the random errors by their very nature tend to cancel themselves. So, when the surveyors are skilled, kung masyadong skilled yung surveyor mo, pwede niyang ma-cancel or ma-eliminate yung ating random errors and through a careful in measuring. So, random errors will be little significance except for kung gumagamit na tayo ng mga high or mga precise na mga instruments. So, pwede siyang maging insignificant. However, these random errors were resulting from an unskilled or careless work do cause a problem. For example, yung GE natin or your surveyor natin is hindi masyadong skills, it can cause some of the random errors. So, it is produced by irregular causes that are beyond the control of the observer. So, this variation results from the observational errors which have no non-function relationship. So, pwede lang siya gamitin ng mga probability models para ma-cancel out natin yung random errors. We have here precision versus accuracy. So, in the past slide, we discussed, we mentioned what is precision and why we need to conduct a survey precisely or accurately. So, when we say this one, precision, it describes the refinement of measurement process and the ability to repeat the same measurement. Again, ability to repeat the same measurement with consistency, small variation in the measurement. That is precision. So, pag-repeat mo ng measurement, and tapos, with consistency pa yung mga measurement mo, maski hindi pa siya yung accurate na measurement, as long as consistent yung survey mo, that is a precision, high precision. When we say naman accuracy is when you hit the target. That's it. So, relationship conformity between the value of the measurement and the true value. So, when you hit the target, anong target na value ng measurement? That is accuracy. So, I have here an illustration to differentiate precision from the accuracy. So, from the upper left side, andito yon C. Low accuracy, but why? Because they don't hit the target. Low precision because hindi consistent yung kanilang mga position ng mga points. Upper right side, we have low accuracy. Low accuracy siya because hindi nila na-meet yung ating target. Okay. While here, high precision siya because itong isang grupo that is, which means conformity yung mga measurement niya. Yung mga measurement niya, 1, 2, 3, 4, 5, 6 tries niya is with conformity and consistency yung kaniyang values. We have here naman high accuracy. High accuracy siya because they hit the target. So, actually, some of the target hit the bullseye. Low precision because hindi naman siya consistent sa kanyang mga value. Mayroong mga value na kalabas na meron sa loob ng target. We have the good observation we have here. High accuracy. So, na-meet niya yung target and high precision. So, yung mga values niya is consistent and yung consistency pa naman ng mga value that is the exact. So, na-hit niya yung target. So, this is what we want in conducting a survey. High precise and highly accurate na survey. Another we have, this example here is high accuracy siya, but low and precision. So high accuracy, some of the values falls on the target. We have here this one, high precision because consistent siya, and high accuracy because na-meet niya yung target. We have here naman, low accuracy because less lang yung number of targets but we have here low precision because walang consistency ng mga values. Some of the values are out of the target. We have here naman sa baba, low accuracy, walang values na nakahit sa target but consistent naman siya sa kanyang measurement, yung value niya. So this one. Okay. So we have here residual, probable error, and weighted observation. So what are these terms and what is the use of these terms in conducting a survey? So let's start. Let's start with the residual. So residual is sometimes called a deviation. So defined as the difference lang ng ating measure na quantity and its most probable value. We have here term most probable value. Or example, ito yung ating mean na observation. For example, yung grade mo sa math is 85, grade mo sa Filipino is, di ba, i-add mo lang sa lahat, tapos divided by the number of subject. That will be your average. So, this is the same kan, most probable value. So, where your residual, your deviation is equals to V. Your V is the residual. Your X bar, itong X bar, is the most probable value. And your X is the measured value. So, you can compute your residual by subtracting only your measured value from the most probable value. When we say probable error, a quantity which, when added or subtracted from the most probable value, defines a range within which there is a 50% chance that the true value lies inside or either outside the limit. So, medyo confusing yung definition niya. So, we can have an illustration. For example, this is where you can write your most probable value plus minus the probable error. For example, you can write 50 meters and example, meron siyang error na 0.01 meter. You can write 50 meter plus minus 0.1 meter. So, where your 50 meter is your MPV, that is your X bar. 0.01 meter, that is your probable error. So, when we say define a range which is there is a 50% chance that the true value lies within or outside the limit. So, meron tayong illustration. If this is 50 minus, that is plus minus, di ba? 50 minus 0.1, that is 49.9. And 50 plus, you have your plus 0.1, it becomes 50.1 meter. So that probable error ranges within plus minus limit. So this one. So your true value of 50 meter lies within that 49.90 up to 50.1 meters. Okay. So we have the formula in computing the probable error. We have two formula. You can hear probable error of any single measurement of a series. So this is plus minus 0.6745, the square root of the summation of your residual square over n minus 1, where your v is the residual, your n is the number of observation. Another for the probable error of the mean. So it's just the same. You just add you just multiply n over n times 1 on the denominator under the square root. Okay, let's use this formula. So when we say relative error or precision, this is expressed by a fraction having the magnitude of the error in the numerator and the magnitude of the measured quantity in the denominator. So I have here an illustration. For example ulit, ito yung 50 plus minus 0.1 meter. Kanina ginagamit natin yung ating 50, yung MPV, 0.1 is the probable error. Paano natin siya gagawing relative error or relative precision, your RP? So, yung ating numerator again, by definition, is yung magnitude ng ating error. Ang yung denominator niya is yung measured quantity. So 0.1 over 50 meters. So to simplify this one, to cancel out meter, because your relative error is unitless, so your 50 divided by 0.1, so magiging 50 multiplied by 0.1, this is 500. So magiging, that is 1 over 500, or 1 is to 500. Which means for every 500 meter measurement, meron kang error na 1 meter. Okay, gets? For every 500 measurement, meron kang error na 1 meter. So you have here an example problem. So here, a surveyor measures the length of a barangay road using a measuring tape in meters. He measures the length 6 times as follows. So yung road, for example, yung both end ng road is road um, point A to point B. Measure niya yung isang length ng road 6 times. So yung nakuha niyang value is almost the same, which is precise naman yung kanyang measurement because consistent ang kanyang values. 100.58, 100.48, 38, 0.48, 0.40, and 0.46. Now, we're going to determine the most probable value, determine the probable error of the single, and probable error of the mean, the final expression of your MPV, and the relative precision of the measurement. Now, let's try to solve this one. Una, we are going to solve the MPV. So this MPV, again, this is just the mean. So you write here all of the observation, you add. So the sum would be 602.7 meter. So that would be the MPV is, you take the sum divided by the number of observation, that is 602.7 divided by 6, that is 100.45. That would be our most probable value. Second, we are going to compute now the probable error of the single measurement and the probable error of the mean. So probable error for single measurement of a series, we have PE is equals to plus minus 0.6745 square root of the summation of your residual squared n minus 1, where your summation of your residual is equals to summation of your V, where n is the number of observation. So I have here the solution. Plot ko na. We have first residual, which is equals to 100.45. This is your MPV. This area here. Ito ang ating MPV. This one. Minus, ito yung individual na measurement, 100.58. Ito yung 100.58. 100.40. Ito yung 100.40. 138. And so on. Diba? So, you subtract. That is just equal to negative 0.13, positive 0.45. So you take the sign, ha, and algebraically sum, take the sum of these numbers. So kailangan natin is yung residual squared. So kailangan natin i-square yung ating mga residual. So you copy lang muna. So i-copy lang natin siya. So this 0.13 is the same dito. So, you copy other. So, 0.05. You have 0.05. And you take the square. So, it will become. So, you check on your calculator if my solution is correct. So, we have here 0.0169. So, you just take the sum, all of this value, because we're going to compute the summation of the residual square. So, sum of that is now 0.0287. So, that will be your summation of the residual square. So, to finally compute the probable error, we have going to use the formula. So, 0.6745, the square root of 0.0287 divided by n, which is 6 minus 1. So, magiging 0.05 ang ating probable error of a single measurement of a series. Okay, for number 2, letter B, which is we're going to determine the probable error of the mean. Same formula, dadaglagan lang natin siya ng n dito sa baba. So, 0.6745 square root of 0.0287 divided by 6 times 6 minus 1. So, the answer would be, probable error of the mean is plus minus 0.05. 2 meters. Okay. So, final expression for your MPV, that is 100.45, this is your MPV, plus minus the mean probable error of the mean. Okay. So, at home, you try to compute the relative precision using this value, 100.45 plus minus 0.02. So, what would be the relative precision of this survey? Okay. So, we have here weighted observation. So, degree of reliability lang siya. So, depende kay GE kung para siyang parang magbibigay ka ng reliability sa isang measurement na ginawa mo na alam mo na yung value na yun is medyo precise, medyo accurate, comparehan iba nga mga measurement. So, usually, this is based upon the judgment of the surveyor. So, it depends on the surveyor. Number of measurement taken for a particular quantity. For example, nag-measure ka ng distance, 10 times mo siya tinry na sinukat. Compared sa isang beses mo lang siya sinukat. Siyempre, mas preferred mo yung mean na makukompute natin sa 10 beses mo siya sinukat. So, mas bibigyan mo ng malaking weight si number of observation na higher. So, we have here the assumption that it is inversely proportional to the square of the probable error. When we say, pag malaki yung error, huwag mong bibigyan ng malaking weight. 'Di ba? Pag may nag-u-occur na error sa isang measurement, huwag ka doon maglagay ng weight. Okay. Illustration, so you have here, nag-assign siya ng weight kay first measurement, 110.26. Yung ini-assign niya na weight is, you have here, 6. So, 110.13 is 2. 110.20 is 3. 110.31 is 1. So, in this scenario, posibleng si GE, na-measure niya yung 110.26 na measurement 6 times. So, 6 number of observation. So, as you can see, mas malaki yung kanyang weighted length compared kay one time lang niya mineasure. For example, si 110.31. So, isang beses lang niya dinetermine yung distance ni this point here. So, you can have a greater weight, ibibigay mo ng greater weight yung measurement mo na mas sinukat mo ng maraming beses. Okay? So, have here for the next topic. So, we have the interrelationship of your errors. So, we have two, the summation and the product of errors. For the summation of errors, gagamitin siya. For example, kumukuha tayo ng perimeter. Perimeter, di ba yung perimeter, i-add lang natin yung mga length ng sides ng particular polygon. So, pag yung every measurement natin ng length sa side ng polygon, may error, syempre, yung kanyang error is nag-a-add up din. So, you can, this is the summation of the error. So, we have here an example where your PE of the sum, that is the probable error of your sum, P1, and your PE2, that is the individual probable error ng kanyang measurement. So, we have here an example. So, a triangular shaped tract of land, meron siyang triangular na we have here, has a side A, meron siyang side A, yung length niya is 35.02, si side B, meron siyang length na 22.12, si side C is meron siyang length na 12.65. Pag measure niya kay side A, meron siyang nakuhang error, which is 0.05. Pag measure niya naman kay side B, meron siyang nakuhang error na 0.03. Pag measure niya kay side C, meron siyang nakuhang error na 22 error na 0.03. I mean, so 0.03. So, to compute, gagamitin mo lang yung formula kanina. You have here, to solve the perimeter of the triangle, we all know that the perimeter is equals to A plus B plus C. So, that is the sum of all the length of a triangle. So, we have 35.02 plus 22 plus 15 plus 12.65. That would be equal to, so you solve. If you take the probable error of the perimeter, that is just the plus minus the square root of the perimeter squared of each observation. So, si 0.05 square plus 0.07 square plus 0.03 square, you take the square root of that value, that would be now the probable error of the sum of the triangle. Okay? Another is, we have product of errors. What if naman, so example, area. To get the area, for example, rectangle, that is length times width. So, what will happen? We can use this formula. So, pag may mali, pag measure natin ng length, and we can have also error in determining the width. So, the product must also contain a probable error. So, that is being called as probable error of the product. So, how are we going to compute the probable error of the product? That is just equal to plus minus the square root of Q1. What is Q1? That is your measured quantity. For example, si length. PE2, that is the probable error of the one quantity. For example, si width, meron siyang error. Q2 plus, your Q2 is the another measured length. Kung kanina si length yon, ngayon is si width times the probable error ni length. Parang nag-interchange lang siya ng value. So, we have here 1. So, ipapartner na si probable error na number 2. Si number 2 naman, papartner niya yung probable error ni 1. So, let's have a sample. So, a rectangular lot has sides A, 51.17. So, meron tayong rectangular lot. Tapos si B, yung width niya is 27.30. Upon measuring the length and the width, mayroon tayong nakuhang error. 0.02 kay length and 0.05 kay width. So, we are going to compute now the probable error of the area. So, a solution to solve the area of rectangle, again, that is length times width. We all know that one. So, you compute the area. For the probable error of the rectangle, probable area of the product, that is, yung to is the formula. So, 51.17 times 0.05 squared plus 27.30 times 0.02 squared. So, you solve the, what's the answer at home? Okay. I would cater questions regarding this presentation, including the last presentation and the videos from part 1 to part 5. You can send a message or drop a message on the comment box of our FB group where I posted all the videos so that your classmate also can see your questions. Maybe you have the same questions. You can raise your question on the presentation, or you have something to ask, you can send an email. So for this time, I'm going to send to you the activity, the problem sets, and next week we'll be posting, and we are going to start na the chapter 2. So keep posted. Check your email from time to time. So thank you for your time. So this is the end of the lecture, chapter 1.